In this lesson, we're going to look at how to solve open sentence equations and to solve open sentence inequalities. How can you use open sentences to stay within a budget? The Daily News sells garage sale kits. The Spring Creek Homeowners Association is planning a community garage sale, and their budget for advertising is $135. The expression 1550 plus 5n can be used to represent the cost of purchasing n plus 1 kits. The open sentence 1550 plus 5n is less than or equal to 135 can be used to ensure that the budget is met. A mathematical statement with one or more variables is called an open sentence. An open sentence is neither true nor false until the variables have been replaced by specific values. The process of finding a value for a variable that results in a true sentence is called solving the open sentence. This replacement value is called a solution of the open sentence. A sentence that contains an equal sign is called an equation. A set of numbers from which replacements for a variable may be chosen is called a replacement set. A set is a collection of objects or numbers. It is often shown using braces and is usually named by a capital letter. Each object or number in the set is called an element or member. The solution set of an open sentence is a set of elements from which the replacement set that make the open sentence true. Okay, you may know a better way than using guess and check, but I'm going to model it here. They asked us to find the solution set for 4a plus 7 equals 23 if the replacement set is 2, 3, 4, 5, 6. So first we're going to replace a with 2, and 4 times 2 is 8, plus 7 is 15, which is not 23. So we're going to call that a false. And when we substitute 3 in, 4 times 3 is 12, plus 7 is 19. Nope, not 23. 4 times 4 is 16, plus 7 is 23. Hey, that's what we're looking for. Now, since this is an equation, there should only be one true solution. They went ahead and did 5 and 6, but once you're at the true, the others should be false. So our solution set, the only real number that makes this equation true is 4. And they wrote it in a brace, which is lovely. Okay, so same thing. I'm just going to write it out by hand this time. You get to deal with my chicken scratching. So we're going to substitute in 2 every time there's a b. So 8 minus 2 is 6 times 3 is 18, and that does not equal 6. 3 times 8 minus 3 is 5 times 3 is 15. Nope. 3 times 8 minus 4 is 4. 3 times 4 is 12. Getting closer, but still not there. Let's try another one. 8 minus 5 is 3. 3 times 3 is 9. Nope. Last chance. 3 times 6 minus... Oops. Got ahead of myself. 8 minus 6 is 2. 3 times 2 is 6. 6 equals 6. That's our true. So the only value that makes that equation true is if b this time, equals, it has to be exactly 6. Okay, instead of just being an algebraic expression, they put an equals case, so now it's an equation. All right. We're still going to use PEMDAS. So 8 plus 2 is 10 inside my parenthesis. 18 minus 5 minus 3 is 2 inside my parenthesis. And then I've got 5 times 10 is 50. 18 minus 2 cubed is 8. Copying down my 50 yet again. 18 minus 8 is 10. And finally, 50 divided by 10 is 5. Ta-da! Gotta love good old PEMDAS. So we did parentheses first, then we did our exponents. We didn't really have a lot of, well, I guess we took 5 times 10 was our multiply, divide, add and subtract. And then the last thing we can do in our order of operations was that grouping symbol that was 50 divided by 10. An open sentence that contains a symbol less than, or equal to, greater than, or greater than or equal to is called an inequality. Inequalities can be solved in the same way as equations. So again, we have a chart, and we're going to replace z, this should be a z, with 20. So 20 plus 11 is 31. Is that greater than or equal to 32? No. Let's try 21 plus 11 is 32. Is that greater than or equal to 32? Sure. So 22 plus 11 is going to be 33, and of course that works. And as we continue on, of course they're going to keep working because we're getting bigger. So 34 is also greater than or equal to 33. And what do you know about 24? It is also greater than or equal to 33. So the values that worked were, the only one that didn't work was 20. So 21, 22, 23, and 24. A four-wheel drive tour of Canyon de Chile National Monument in Arizona costs $45 for the first vehicle and $15 for each additional vehicle. How many vehicles can the Velo family take on the tour if they want to spend no more than $100? Okay, so let's get an algebraic expression to represent what they said. So $45 for the first one, no matter what. And then I guess if you come with a group and you have more, then each one is going to pay $15 for each additional vehicle. And they want to spend no more than, so they could spend up to exactly $100. Now, we're already starting with one vehicle, so N is vehicles more than the first one. Now, they could just take one vehicle in, so then our N would be 0 because we're adding no additional vehicles. So 45 plus 15 times 0 is 0. So is 45 less than 100? Yes. They could do one additional vehicle. So 45 plus 15, that still works. 60 is less than 100. 45 plus 30 is still okay. 3, are we still rolling? 45 plus 45. Yes, we are. But 45 plus 60 is too much. So the question was, how many vehicles can they take? Okay, so this is actually additional vehicles. So they could take, the first one would be 1 plus 0. So they could take one vehicle, 1 plus 1. They could take 2, 1 plus 2. They could take 3, 1 plus 3. They could take 4. And so that's it. So the choices is either 1, 2, 3, or, wow, that's a large family to come in 4 different vehicles all at the same time, but I guess they could. Open sentences are solved by replacing the variables in the equation with numerical values. Inequalities like x plus 2 is greater than or equal to 7 are solved the same way that equations are solved.